I'm MC Toon, and it's Tuesday night. Welcome. Tonight I've got a debate with Tyler. And let me get this on here. Welcome, Tyler.
Thank you, McToon.
You can call me MC Toon or Mike. It's MC like MC Hammer.
Okay.
I'm not Scottish. I get that a lot. It's okay. Marcus is saying sorry for the timeout. So Marcus Dresden timed him out. Tyler or somebody using Tyler's account made a comment and got timed out for no reason. Marcus, I might consider bringing you back, but you got to be good. Anyway, somebody says you got to water that tree. It's
metal.
Yeah. Is it heavy metal? Because I love me some heavy metal.
You know what? Could be, yeah.
I'm guessing it's actually aluminum, which isn't that heavy. But why don't you take a minute to, if you want to introduce yourself, Tyler? Go ahead.
Sure. Yeah, I've been in this game for quite a few years. Initially, what piqued my interest in this, and it was even before I knew anything about flat earth or whatever, or even really heard of the concept, was I worked in telecom back in 2001 as a senior executive. And we had a company that was based here in Salt Lake City. That it was an aviation company. And they had bought a bunch of land out in the middle of Arizona, out in the middle of pretty much nowhere. And they wanted to have high-speed internet installed in this facility because they wanted to move their entire facility over there. But in the meantime, they needed to transfer their documents, their blueprints from their plane designs, which were giant files, to their facility in Arizona. So we took on the project, and so my IT guy went down there. He actually drove down there, scoped out the facility, came back and said that, okay, well, we're looking at about a $400,000 contract, and put that all together. The company agreed that they would pay that amount to put in the infrastructure to give them that access. And we all assumed at the time that satellite internet was a possibility. Well, after that, we spent the next month calling every single satellite company that we could find on Google, and it was the lines were disconnected, or you're leaving voicemails or whatever, no calls back, no nothing. And after about 6 weeks, my IT guy and his coworker, they come back to me and just says that none of these companies are answering their phone calls. They're not returning phone calls. And then another couple weeks went by, and then he just come back to me and he says, you know what, I've done some research, and he says there's no satellites up there. He's like, there's no way we can get them high-speed internet in the middle of the Arizona desert. So basically the best we can do is multiplex their copper line and give them, I think we were able to give them like 256K was all. And so
what year was this?
This was in 2001. And so the $400 and something thousand contract turned into a $600 deal. And, you know, in the end, I was working with their IT guy, and, you know, I just, at the end of the day, I just kept scratching my head. I'm like, how is you're supposed to be able to get satellite internet out here in the middle of the Arizona desert, but it's not possible. So that's really where this all started. You know, I didn't ask for, you know, I believed we were on a ball. I believed all the other stuff we were told. But
So in the end, did you just muck some ISDN lines?
we multiplexed their copper wiring. And
Was it ISDN or were you using just phone line modems?
It was basically phone line. Yeah, that's all it was. 'Cause it was literally out in the middle of nowhere, but all they had was a copper line. We were looking to run fiber and do all this stuff, and but when the whole satellite internet thing fell apart, I was just like, what the?
So maybe you just want to go and buy some Starlink service right now and check it.
Oh, well, that's over and done with. That was with Quest Communications.
Yeah, but I mean, today, just to see if satellites exist, you could just go, get Starlink, see if it happens, see if it works.
Maybe so. I don't know. But that was what triggered my my journey down the rabbit hole was that whole thing, and that took me all by surprise. And
so now, are you aware that Elon Musk just sent a whole bunch of Starlink base stations to the Ukraine?
Yeah, I'm aware of that.
So how is that data getting sent?
I haven't looked into that. I'm not sure.
I would suggest you look into that. I mean, you sound like you know the technology a little bit. So,
hey, I'm not saying I'm not going to dispute the Starlink thing. I mean, it might be a great innovation to to be able to do stuff like that. But back in 2000, no, none of this stuff, none of that even existed. So anyway, that's kind of my start on this whole thing.
Okay. So, well, other than your inability to get satellite internet service when it wasn't very commonplace, why do you think the Earth is flat?
Well, I wouldn't really call myself a flat earther, but I've gone out to prove myself wrong, like thinking that I was missing something 8 inches per mile squared. I've done laser tests. I've got two P900s. One is infrared modified. The other one's just a basic one.
So now, hold on. How long have you thought this?
Or with the flat Earth?
Yeah.
It's probably about 4 years, 5 years.
So 5 years and you still can't get the right formula?
It's never been proven.
No. If 8 inches per mile squared is the wrong formula. Didn't you ever research to get the correct formula?
That's the official formula they tell you.
No, it's not.
Curve.
No, it's not. That's the official formula that Samuel Robotham came up with, and everybody has parroted it since then, but it's always the wrong formula for predicting the amount hidden because it has no way to take into the observer's height.
Okay.
But well, so in 4 years, you never came across the fact that that's the wrong formula?
I was a moderator in the original official Flat Earth group and Globe discussion group with 130,000 members.
Yeah.
And
well, it was an echo chamber for the most part. So nobody was allowed to come in there and say that's the wrong formula. They'd get booted.
I never even saw that.
All right.
It's always been 8 inches per mile squared.
All right. So that is definitely an echo chamber formula. The correct formula includes the observer height.
Sure. And if you go to the Earth curve calculator on Metabunk, it is based on 8 inches per mile squared. So if you're correct and Metabunk's wrong, then Metabunk again is full of garbage.
Metabunk does not use that formula either.
That's on their Earth curve calculator.
It does not use that formula. It absolutely does not use that formula.
It sure does.
Well, we could go to it right now, couldn't we? We could see what it says about the formula. mean, you're pretty confident in your claim that they use that formula.
Mm-hmm. That's what they've said from day one.
All right. Let me prep this here. I should have prepped this ahead of time. I didn't prep this screen here. So where on the screen, just to be sure, where on the screen does it have the formula on Metabunk?
For
Because you said it's on there. I just want to. All right, so I'm going to share this so you can see what.
You can just
see
do it right there. Just Google Metabunk Earth curve calculator.
Yep,
It's right there.
I got it.
Yeah.
All right. So now you're seeing it. Okay. Let's see if 8 inches per mile squared is on here anywhere. It's not. The formula, 8 inches per mile squared, is not on there anywhere. It's not on there.
If you do the math, when they talk about distances and her viewer height,
Yeah.
it all comes down to the 8 inches
okay.
per mile squared.
8 inches per mile squared. Where do you put in the viewer height?
Right at the top there.
No. In the formula you quoted, 8 inches per mile squared. Where's the viewer height?
It's right at the top.
No. In the formula, 8 inches per mile squared. Okay, I'll stop sharing the screen so you're not confused by it. The formula, 8 inches per mile squared. Where, using that formula, where do I put in the viewer height?
Let's see.
No, just answer the question. Where in the formula 8 inches per mile squared?
That's what it's based on.
Is viewer height.
Let's see.
All right, so maybe the author of that website would be the person that we should go to see.
That's Mick West.
Yep. And so we should ask Mick West what he says about that formula, right?
Mm-hmm.
So let's see what he says. Hold on a second. I'm sharing the wrong. Hold on a second. Get out of here. There we go. So here is his post talking about that calculator. Right here. Doesn't say inches anywhere on there. Hey, Rory's in there. Look at that. So now he does right here. Oh, look. You see this? There's a formula.
Okay.
That's not 8 inches per mile squared, though. You see, 8 inches per mile squared is never the correct formula in and of itself to get the obstructed amount. Now, this calculator is okay, but it doesn't allow you to customize the refraction. So if it's little refraction or a large amount of refraction, you don't know. So it's an estimate. And if you look at the bottom, somewhere on here, standard refraction is an approximation of refraction expected under average or standard atmospheric conditions. Actual atmospheric conditions can vary greatly, and the resultant refraction can be complex, especially close to the horizon.
Sure.
See here for source of this approximation. See here for historical usage of this approximation. For a more detailed simulation of the effects of refraction, see the Metabunk refraction simulator. So this is for the simple case.
Yeah.
Okay. Now I have I have seen very, very few instances where this doesn't do a spot on job. And those instances are always where the refraction is high. And we also see this not accurate for observations over water very close to the horizon. Now, when you've done laser tests, has it been observations over water very close to the horizon?
We did it down at the Bonneville Salt Flats.
Okay, but was it over water very close to the horizon? Was there water on the salt flats at the time?
No.
Okay. And then did you do it at on an overcast day, or did you do it on a sunny day near sunset and after sunset?
I can't remember if it was overcast, but I remember I was wearing shorts and a tank top. The ground was dry.
Okay. Now, so have you studied the effects of refraction so that you can speak to how it does, what it does, or did you just kind of ignore it and think that it didn't exist?
No, you can argue refraction all you want, but the thing is when the ballers they'll show ships and whatever over the horizon, or the what was it, the spinning wheel things out there in the ocean, but
windmills.
You can say that they can all say that there's, you can't see the boat across the horizon this way, but if you use a wide angle lens, your y-axis is always level, and it should be both ways. You just can't have a level.
And did you do the math to calculate how much was expected left to right curve? So let me give you this.
Sure.
This isn't bad. The Metabunk calculator is okay, but you cannot customize refraction. If you want to get advanced, you use the advanced Earth curve calculator from Walter Bislin. And in here you can see you can adjust the refraction. So you see when I drag that slider, it lets me adjust the refraction. So when you're looking over water,
right,
on a day that was not too extreme, you'd want to have 0.33 on there at the very least.
Okay.
If there's a good temperature differential between the water and the air, you'd want at least 0.50, maybe more, maybe 0.7 or 0.8.
I've not used this before, so.
Okay, so if you ever are going to do something where you're like, well, the globe math doesn't work. This is the globe math. 8 inches per mile squared is not anything even remotely close to the formula to give you the predicted hidden. And I can demonstrate that to you even better. This has a fantastic picture here. See that picture? This shows the difference between what 8 inches per mile squared gives you and what the correct formula gives you. So if you look at from the viewer height, you see that dot that's right on the surface of the curve.
Sure.
And then a dashed line over to the right that says surface level, and then there's a line that says drop. Right. That drop there, that is approximately 8 inches per mile squared. Now look, the viewer height is up there a little bit. You see that? Yeah. And then you have, I don't know what color is that, a green line going diagonal down. You got an X on the horizon. It keeps going, a dashed line, and then you have the dot, and then you have hidden. You see where it says hidden?
Yep.
Okay, so same Earth, correct formula. Hidden is the correct amount. Drop is the wrong amount. Do you see the drastic difference in size between them? Right, so the hidden amount is significantly smaller than the drop amount. So the predicted amount hidden is much smaller than the drop, which is what 8 inches per mile squared is. So 8 inches per mile squared is actually a lie, and it's deceiving people into believing something that's wrong. I don't think that you want to be the deceiver, correct?
No, but
okay,
that's what.
So don't say 8 inches per mile squared unless you want to be a deceiver, right?
That's what it's been.
It's never been that.
This is the first anyone's ever even said
Because you've
mentioned
been in
this.
an echo chamber.
Well, you can prove you can say on the x-axis that ships go over the horizon, but you can't prove.
Okay, let's not change the topic just yet. I'm happy to change the topic to this one, but let's just wrap this up first. Can we agree that the correct formula should be used? Right?
Sure.
Okay. And so to make it easy, because I would rather not do the formula by hand, when it can be done on a computer here. But just so you know, right here, number 4, that's the correct formula.
Let's see, remember this. Number 4. Okay, so RRCOS.
Yeah. And you see there in the bottom, the denominator of the arc cosine has h sub 0. That is the viewer height.
Mm-hmm.
So.
Okay.
So you also, this one here, the Metabunk one is written in JavaScript. If you really want, you can look at the source code and look at the JavaScript source code. I don't know if you're a developer or not. I am. I can look at the source code, or you can have a developer friend look at the source code to see what they're actually using.
Cool.
So, okay. I'll stop that. Now, you were talking about the left to right curve.
Yep.
Okay.
Never been proven.
And what do you mean by proven when you say the word proven?
Can I do a share screen?
Well, can you just let's make sure we know what terms mean. When you say proven, what do you mean?
On the y-axis, like
no, just in general. When you use the word proven, what do you mean?
Well, everyone was having so much fun with the with Soundly's photo.
No, please. I just want to define terms. Soundly's not involved in the word proven. That's just a generic thing. If you're walking up to somebody on the street and they said, "Hey, can you tell me what the word proven means?" What would you say? You wouldn't bring up Soundly, would you? You would give them your definition of the word proven.
Well, I bring that up because that was the #1 photo supposedly showing the Lake Pontchartrain power lines curving.
Back to the topic. What does the word proven mean?
Prove the X and Y axis.
No. Just in general. Not related to the shape of the earth. Not related to Soundly. Just in general, when you're using the language of English, what does the word proven mean to you?
Can you prove it or not?
You don't use the word prove when defining prove. That's kind of dictionary 101. You don't use the same word to define itself.
Okay. Well, then how do you see it? Because if you can't prove something, then...
No, I'm asking you to define the word that you used. You've already used that word, so you have a bunch of meaning behind that word. I want to know what meaning you've assigned to that word so that we can be on the same page on what the vocabulary is in our conversation.
I just said it. If you can prove it, then document it and share it, and there you go.
Okay.
If you can't prove it, then it's not proven.
Okay, so when you say prove, you mean documented.
Yeah.
Okay, so maybe to reduce confusion, we could say document. So nobody's documented it.
Well,
because prove has a lot of different meanings, and within science, scientists don't like the word prove because it's binary and it's forever.
Okay.
So they generally try not to use it. Common language, it gets thrown around a lot. So I try not to use it.
Okay. All right. I'm not going to get into the language stuff because you already battled that on Sunday night. That was pretty comical, but
okay.
Yeah.
So let's say document. Can we do that? I like that. I'm perfectly fine with document.
Okay, document. Yeah.
Okay.
I mean, if you can take a camera and go wherever you want and try to prove
document
that, document it. I've been to Canyonlands, the Grand Canyon, again, the Salt Flats. And, you know, in the Canyonlands, there's mountain ranges that should not be visible, and you can zoom in and see the entire mountain ranges.
Okay, but now when you say should not be visible, did you use the Metabunk calculator or did you use the Walter Bislin calculator? When you say should not be visible, or did you use 8 inches per mile squared, the wrong formula, which is for deceivers?
The other calculator, I can't remember what the other calculator was, but the Medevac one is kind of the same. But when you're shooting over 50, 60 miles and you can see an entire mountain range from bottom to top, I mean, that's documented, and I've got it on video. I've got
and how high were you, and what's the topography between you and the other mountains?
Just standing on the ground with my tripod.
Yeah, but what was the elevation?
The elevation of what?
You.
6 feet.
Okay. 6 feet above water? Like 6 feet above sea level?
6 feet on the ground. Okay. Just standing on one side with the tripod, and then zooming in on the mountain range 50 miles away.
Okay.
You can see the whole thing.
Okay.
So
sounds like you did a pretty sloppy observation. So maybe, unless you want to bring that up, like show it to me, maybe we want to not just talk about things. I'd love to see it if you have it, but I'm going to ask your location, your elevation, the distance to the thing you're looking at, and if it's not over water, then the topography between you and there, right?
Let me see if I can. I've got a ton of videos. Give me one sec.
But did you document those things? Because if you didn't, that's my first question. And if you're going to say no, then you know.
Let's give me a sec here. Let me find it. I've got way too much stuff in here. Sorry. Let's see.
Mr. QTube is in the chat. He says, you mean the group who blocked everyone debunking flat earth? That Facebook group? Yeah. I applied. I was blocked. I was talking to an admin in real time. He removed the block. I applied again, and I got blocked before he was able to approve me. That's how open to conversation that group was.
Yeah. I wasn't that. I was a mod in there, and I had the ability to block people. You know what? I never did that with the Glovers unless you know they were making fake accounts and stuff. But otherwise, I always appreciated just an open debate in that group. And yeah, there were a couple people that were pretty, not too fair with other people. And you're right, echo chamber.
Yeah, Nathan Thompson is the name of that person that doesn't like people that challenge him.
And I know Nathan, and he is a crazy dude.
Well, we agree there. All right. Did you? I mean, before you pull it up, don't bother going to pull it up, because if you don't have the information, then it's going to go nowhere. Because as soon as you show it to me, I'm going to say, "What's your height? What's the distance? What's the topography between you and the other side?" And if you don't have that, then it's pointless. It's just a sloppy observation.
No, I've got it. I just thought I had it loaded into this other folder, and I'm not seeing it. Damn it.
All right. Well, I'll read a couple of the Steve-O, not that Steve-O from the not Johnny Knoxville's friend. Says that's 5 years of research gone down the drain.
Mm-hmm.
It's a tough crowd, man.
Yeah, I expected. No big deal.
Zoomy says, is it 8 inches per mile squared on Lake Titicaca, bro? No,
That's cool.
it's one of my favorite lakes.
Let's see. We get.
No,
Dun, dun, dun.
I'll keep going while you're looking. Green Bull
Yeah.
says the bane of every flat earther continues to be high school level math.
Well, the 8 inches per mile. Okay, here it is. All right.
You found it?
Yeah, let's do this. So this was just with my tripod. Let's see. Let me go full screen. Since we're learning this. Well, let me move this over. Okay. That's 50 miles away. So.
Okay, and how do you know it's the bottom? Like, how did you confirm? There's clearly layers of things in the way. So, all right. So that's what was your elevation?
Like I said, it was just me with the tripod. So
Okay, I told you. I said if you don't have the details, then it's pointless because we can't even test to see if it should be matching the globe or not. You can't even test if you don't have the details, right?
I'm not sure what you're getting at because
You
that
can't
right there.
You can't test to see if the Earth is a globe if you can't actually calculate the what you should or should not see on a globe. So how do we calculate what should or should not be seen on the globe if you don't have any of the details of it? How do you know this is not possible on a globe?
There's never been curve proven on the y-axis.
Okay, for this particular observation, which is not a y-axis observation, right? How do we know what is supposed to be seen on the globe? Did you do
There's
that?
Supposed to be,
did you calculate the consequences of that?
Because there's supposed to be curve.
How
Where's
much?
the curve? Where's the curve?
How much curve should you see?
At least some.
Okay, how much? And how do you know that you did not see it? Because you cannot see the bottom of those mountains because there's layers of other hills and things in the way. So you can't see the bottom as you said you could. So how do you know how much curve should be seen to know whether or not the Earth is what you're seeing is what it's supposed to be? If you didn't do that math, you didn't do anything other than take a nice video.
Okay, let me ask you, do you have any video that you've done that actually shows curve that according to your measuring
Yes.
formula?
Yes, there is.
Let's see it.
Okay, this is by a flat earther, Dwayne Kellum. You know Dwayne Kellum?
Yep.
So
he's in Colorado.
So I'll share my screen so you can see. People at home are seeing it right now. So Dwayne Kellum used a Sony camera, a full frame Sony camera. It's a A7S2 right there. The lens is a Sony FE 50mm f1.8. Right now, we would not want to use a fisheye lens or something with heavy barrel distortion. So I looked up this particular lens to see its properties. This website here analyzes lenses so people can be informed when they buy them, thedigitalpicture.com. And so there's a link to it right on my website at mctoon.net/Dwayne Kellum. Here is the distortion introduced by that lens. Do you see that?
Hold on, let me get this out of the way. Okay, yeah, okay, go ahead, keep going.
Right, so that is from that website. The distortion introduced by the lens, which is they have the black and white, which is the distortion, and then they have these vertical and horizontal lines, which are straight. And if you look at them, they match.
Sure.
So this lens is not barrel distortion. It does not have, certainly not fisheye. It's a rectilinear lens. Very, very, it's no perfect rectilinear lens, of course, but this is a very rectilinear lens. Any curve that you see will be curve. Any straight that you see will be straight. So here's the video. High altitude balloon 24. I have it queued up right to the spot. This is at
yeah, I know this video.
117,000 feet.
Mm-hmm.
So right there, and you can see the curve with your own eye.
See, there's your optical illusion right there, because where the sun hits in the center, you can take a flashlight to a shoebox and actually it'll make it look like the shoebox is bending.
Okay, but here's what I did. You asked for the curve. Here's the curve.
Yeah.
So if you ask to see the curve and I show you the curve, and then you start making excuses and inventing physical properties that don't exist, well, there's that deceiver again coming back. A little bit of a problem.
No. I've seen all of his videos. It's the light distortion on where the sun's coming through in the center that makes it look like there's a curve, but there's not a curve.
Why would light make something straight look like a curve? That makes no sense.
Because it highlights that section. If you were just showing a section without the sun being right there, then you're not going to see a curve.
So anytime the sun is visible, it doesn't count. Is that what you're saying?
It enhances and makes it look like there's a curve.
Yeah, but you can't see the Earth without the sun shining on it. So basically, you're using a get out of jail free card. Anytime there's a curve, the sun is making it look curved, and the only time you can see that there's a curve is if the sun is shining on it. You see the problem there?
Well, the problem is you're using a video where the sun is just barely it's sunrise. So of course that's going to distort the horizon. But if you use one of his videos where the sun is, say noon or whatever, I've seen all of his videos, then there's not really an argument. But this,
okay, and so what are the physical properties? Can you point me to maybe where people have explored that shining a light on something makes it look curved? Is this a known effect of nature or physics or something, or is it just an invented exit when you get in trouble?
No, you can test it for yourself.
No. I'm asking, where is this documented in physics? Are there some things in the annals of optometry that cover this, or somewhere in optics? Did somebody write their PhD thesis on shining a flashlight on something causes it to appear curved even when it's straight? Where is this, other than just flat earthers making up excuses? Do you have anything?
That's just, anybody can test it. It's pretty simple.
So nowhere. Okay. I've never seen that happen myself, where you just shine a light on something and it looks curved even though it's straight.
We'll grab one of his other videos where the sun's not, where you're not looking at sunrise,
but the sun is shining no matter what, unless, it'd be totally black if the sun wasn't shining. So.
Well, I'm just saying that's another video other than sunrise.
Yeah.
It's pretty simple.
It's pretty simple. Anytime that the light is shining, you say it's this previously unknown effect.
For sunrise, yes. And you can do it with sunset too, but not when the sun is overhead.
Okay,
I use basic. It's
not basic. It's completely invented and never previously heard of before.
Go through all of his other videos. He's got plenty of videos that shows with the sun overhead and the balloon showing the horizon, and nothing's bending.
Well, look at that. More curve. It's always curved. in this video. Always curved.
The only curved part is where the light is shining. It's an optical illusion.
So you say, but you don't have any backing evidence for it. It's just a claim that flat earthers invented to get out of a little bit of a problem they found themselves in.
Well, some might have that problem.
So let's be clear. Let's be clear then. You don't want me, when you say show me the curve of the horizon, you don't actually want that because you already have your lame excuse ready to go to deceive people. So don't ask for a picture or video of the curve of the horizon because you're not honest when you ask that.
I ain't got time for that, man. Like, I don't care. Like, if you want to believe what you want to believe, then so be it.
No, it's your escape mechanism is what's happening here. You asked me to document the left to right curve, the y-axis curve. I gave it to you, and you're like, oh, because light's shining on it, it makes it look curved.
And you're using Dwayne Cohn's video to try to prove that, and he is an absolute flat earther.
Doesn't matter. Flat earthers always get evidence for the globe every time. Ask Ranty.
Oh gosh.
Right?
Sure.
Ranty was great at that. He talks about it all the time now. He's like, I can't believe I kept doing that. So, all right. Have you seen the little piggy camera?
Yeah, of course.
Okay. And what do you think of that?
That was pretty cool back in the day. I just felt like we needed a little bit more than that. I mean, if people go to those kind of lengths to do the balloons and the video and whatever, you know what?
So flat earthers have been using the little piggy camera, about an 8-second section of that video, where the horizon is below center frame, and they claim that it shows that it's flat. Of course, it's below center frame, and they don't mention ever that it is a GoPro camera. Right?
Yeah, I'm not sure what kind of camera they use, but
I'm sure I know. I did the research that flat earthers say that they want to do.
Okay.
Now when you have a camera with distortion like that, when the horizon is in center frame, both left to right center and top to bottom center, that's the least distortion.
Sure.
Right? So I grabbed not just that little 8-second clip that flat earthers always play or send screenshots of. Mm-hmm. I got the largest portion. The original is gone and the owner delisted the video, but here is the portion of it that I could get.
Yeah, I've seen this a zillion times.
So here it doesn't look like it's doing much, but this is just before the balloon pops.
Right.
And it starts moving, and there. Center frame. You see that dot in the middle? Center frame. Now, is this the wrong time of day? Or is this the right time of day?
Well, this is.
I just want to know. Is this the right time of day or wrong time of day? Is the sun shining on it, making it look curved?
Okay, I've not seen this one before, so I'm just being honest.
Okay.
Are you sure this wasn't manipulated? Because in the original video that I remember, this wasn't in there, and I've seen it.
I'm sure. I got the original. The section of the original that's out there still. It's right at balloon pop. You see that? Look at that. The question to you again is this the right time of day or wrong time of day for curve?
I'm not trusting this video.
Oh, so you're just hand waving it.
That was not in the original video. Nope, 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 and nope. Yeah, you're getting the fisheye. Okay.
Yeah, it is fisheye, absolutely. But when it crosses center frame, you see reality.
Okay. So I'm gonna screen share.
Well, let's see the rest of this. Oh, that's all I had. All right. Let's get. There we
Okay.
go.
I'm gonna play the. Can I play a video real quick?
You can.
Okay. It's 2 minutes. So let's do this. And this is how we roll. This is fisheye versus.
You ever think in the United States that false information will be something where you strike it from the platform?
If we are just suddenly saying, like, we believe this to be true, look, like, is the earth flat? Like, I think most people think it's flat. I think it's round. But there are people out there who think it's flat.
A selfie taken at the top of Everest has completely destroyed the flat earth theory, and we're going to talk about it right now on IO. Welcome back to Inform Overload. I'm Charlotte Dobre. Reddit is talking about this amazing selfie taken at the top of Everest, where you can see the curvature of the earth. The post was shared by Reddit user Amazed Spirit with the caption, "Checkmate Flat Earth Society."
I paused the audio just in case it's got copyright stuff on it. All right, you got is it just keep going for a while? Okay. Yep. So I muted the audio in case it's copyrighted. So you know, because it's just music. So okay, I have no idea. So when I okay, all right, I unmuted. Okay, so yep, that was an extreme GoPro. So what?
Yeah. So I mean,
I did not present that as curvature of the Earth. So
this picture right here. Can you still see this one?
Yes.
Okay, so that's a wide-angle lens from a military helicopter, and we measured, and that's a good 250 miles across.
Okay.
How come there's not a goddamn curve in sight?
Well, how much did you calculate should be visible?
It's as straight as can be.
How much did you calculate should be visible?
I didn't calculate anything.
Okay, so then you don't. So you didn't actually have a hypothesis that you tested.
No, but I can grab that picture and draw a straight line across the horizon.
Yeah, and what you can do then is you can say, well, how many pixels based on this camera should I see of curvature?
Yeah, well, there's a lot.
Did you do that? You did not do that. You don't know. You don't know how much curve you should see.
You should at least see a little bit. But
how do you know how much you should see? How did you calculate the consequences of the hypothesis that the Earth is a sphere or flat? You didn't. You just said, well, there should be. That's pretty lazy.
So
how much should there be?
I could take 10 of these photos and put them side by side, and it would still be an absolutely straight horizon.
How much should you see from that elevation?
At least a little bit on each end.
How much? If you don't know how much, then you cannot draw a conclusion.
For 250 miles, there should be about, I think that was about 120 feet that should be bending on both
Okay.
sides.
And how high is 120 feet at that distance in pixels on that camera?
I don't know about the camera. I didn't take the picture.
Okay, so you don't know. You still don't know. What does 120 feet of curve look like at 50 miles away on this camera? You don't know. This is the sloppiest science I've ever seen. And this, you think this crap, the I don't know how much curve should be visible, is actually, for you, proof? That's garbage. This isn't anything. This is, you didn't do your homework.
Where's the curve, bro? Where is it?
I'll tell you, you should not see much curve at that elevation. On a globe, this is exactly what is predicted.
For an ocean to be completely
Absolutely,
level.
100%. This is what's predicted on a globe. Can you do the math to show otherwise? I'll wait.
Didn't know it was going to go to this, but you're just optically, there's never been proof of curve. I don't give a crap.
Oh, well, I already showed you. I'll show it again for everybody at home. I mean, you can repeat the mantra that you don't think there should be curve, but it's right there on the screen for everybody to see. You said it's never been shown, and it's on the screen right now. You're not seeing it. It's on the main one.
Oh.
So.
Yeah, I'm not seeing.
Well, it's the Dwayne Kellum picture. There's curve.
Uh-huh.
So there is as much curve in the Dwayne Kellum photo as the globe predicts.
See, I'm not buying it because in this Everest video, if you actually notice they say that the first picture destroys the flat Earth theory, and he's using a total GoPro. In fact, I think the entire photo was actually photoshopped. But then when
I never used that as evidence for the Earth being a globe, so I don't know why you're bringing it up. It has no bearing on this conversation.
When the guy films at the top of Mount Everest, and he moves his camera just a little bit, and then the horizon bends. Okay,
yeah,
I get
it's
that.
a GoPro. Yeah, exactly.
But then,
what's the point? I didn't bring that up as evidence for the Earth being a sphere. Somebody else did. Bring it up with them in a debate with them, but I didn't bring that up. I brought up the video from Dwayne Kellum, and I brought up the little piggy camera where the center frame was the horizon. Okay, those are the two I brought up. So if you're addressing somebody else's evidence, then why are you not addressing the evidence I brought? Is it because I have strong evidence and this other one is just easy to debunk?
Well,
it's kind of a red herring, isn't it? Definitely a red herring.
It's easy to ride with the camera observations, the way they can bend the horizon and stuff.
Okay, I don't care about somebody else's video, somebody else's thing. I didn't bring it up. So if you're deflecting, it tells me that you don't have an actual answer to the evidence I brought up. You see the problem there? I do.
No. You're using lens manipulation. That's just how cameras work.
I didn't use lens. Yeah, I did.
Okay, so where's proof of, say, the China Bridge that's 110 miles long, and there's zero curve to the construction of that bridge?
And how did you measure that?
I didn't measure it.
Okay, so then why would you bring it up?
Because they didn't account curve into the construction of that bridge.
Show me the construction documents.
It's the longest bridge in the world.
Okay, show me the construction documents that support your claim. You don't have them. Why would you bring it up? You never even looked at them. Why would you bring it up? You're just parroting somebody else. You didn't do your own research. I do my own research. You just parroted.
Mm. All right.
All you did, Tyler, was parrot somebody. You never
It's
looked
based
at
on.
you
it's
never
based
looked
on-
at the documentation. So
It's
why would
based
you make
on-
that claim?
It's based on optical observation.
What is?
With the China Bridge, you can zoom
Okay.
in as far as you want,
Yeah.
110 miles away, and you can see the other side of where the bridge ends.
From what elevation?
Oh, geez, do I gotta pull
Yes,
that
you
up?
do. You absolutely do. 100%. If you make a claim, I will 100% expect you to be able to back it up. This is normal.
Okay, well, I wasn't expecting this, but
Well, then don't bring up a claim if you're not expecting me to expect you to back it up.
okay. I just think you want to argue. I'm not really in the mood, but let's see.
All right.
It's the day on.
Yeah. Well, yeah. While you look up the evidence supporting your claim, I'll do this couple here. Eddie Reese says, how is it that none of the flat earthers can answer a straight question? 99 times out of 10, they'll divert when asked a direct question. Chronic
No.
Avenger says, if you have a 10-foot 2x4 with a slight curve of 1 arc second, I don't know if he means 1 degree, would you notice
Yeah.
it looking at the plank perpendicular or along its length?
So
Okay.
that's the.
And what's
That's
the
the-
elevation of the observer?
Well, you tell. I
No,
don't
it's
know
not
what
my
it
claim.
is.
It's not my claim. It's your claim. So I'm not going to tell you. Your claim.
But-
Obviously, this observer is not right next to the water. They're looking at it from a high elevation. What is the elevation? And then show me the math that you did to predict how much should be obstructed bottom up using the
Point
correct
is,
formula.
you can see the other mountain range, and
Okay.
there's
and,
no curve on the
and-
y-axis again with the wide angle
and,
lens.
and how much curve should you expect on the y-axis at that elevation?
I think on this one, they was around 6,000 feet or something. So that other mountain range shouldn't be visible. It's not a big mountain range, but you can see the entire thing. I mean, there's plenty of other
But
pictures
you never
this.
did the. All right, so you don't have the math of this. You don't know how much should be hidden bottom up, and you don't know how much curve should be left to right. But yet you are bold enough to make a proclamation without having done that basic groundwork? That's ridiculous. That's not science. That's
Okay.
deception. You are deceiving people. Why are you deceiving people, Tyler? Why don't you actually do the work to find out how much left to right curve should be visible and then compare it to the observation? That's definitely what you should do. That's science. That's logic. You didn't do that. You just said, well, I don't see the curve, therefore it's flat. How much curve should you see? You don't even know.
At least some.
At least some. Sorry, at least some is not actually an answer that's useful. You don't know how much. You don't know if there should be even 1 pixel in that camera of left to right curve. You don't know the resolution of that camera even. You don't know the elevation of the observer. So you never could have done the math to figure out how much left to right curve should be there. Here's the thing. If you take a hula hoop and you put it around your head, you put your head right in the middle of that hula hoop and your eyes right at the same height as the hula hoop.
Okay.
You look straight ahead. How much left to right curve should you see?
So you're saying hula hoops round, but it's still flat?
I'm asking you. It's a simple question, right? And to remind you, Eddie Reese just said, how is it that not one flat earther can answer a straight question? 99 times out of 10, they will divert when asked a direct question. So I'll ask you a direct question, and we'll see if
Sure.
Eddie Reese is a prophet or not. When that hula hoop is at the same height as your eyes, and you look at that hula hoop, how much left to right curve should you see?
Dude, where are you even getting at? A hula hoop. It's round, but you can put it on the table and it's flat.
Eddie Reese,
So
you are a prophet.
I'm-
It's a straight question. It's a direct question. The answer is none. If you hold a hula hoop at the same height as your eyes and you look at it, you'll see no left to right curve. If you drop it down to your waist, you'll see that it's definitely curved. The elevation dramatically changes how much of that curve you see. So if you now take that hula hoop back up to your eye height and drop it down 1/4 of an inch, how much curve should you see? Very little. Are your eyes good enough to see 1 or 2 degrees of curve across your entire range of view?
So like something like this. Is that kind of what you're getting at? Like something like that?
That's not a hula hoop.
No, but it's round and it's flat.
Yeah. Now bring the camera down right flush with the top of that.
Okay, then you would see flat.
Yeah.
What?
So the point is, the horizon is a circle around your vision.
Right.
It's like the hula hoop. And when you're at low elevation, like 1,000 feet or less, or 10,000 feet or less, it's the same as if your eyes were right at the same elevation as the hula hoop. Very little curve is there because it's right at the same level. When you drop down the elevation, when you drop the hula hoop down to maybe an inch below your eye level, then you start to see maybe a little bit of curve. Right? You need to get it low enough to see the curve. But if the hula hoop's up there and it's tiny bit below your eyes, you won't be able to differentiate the curve. There's a formula to calculate how much left to right curve you should see based on the angle of view and the elevation. You never applied that, so all of your observations are not useful. Because you can't even answer the basic question, which any scientist is going to ask: how much curve do you expect? Because you make a hypothesis. The hypothesis is based on what's the radius of the Earth, what's the observation of the viewer, what's the camera angle of view, what's the distortion properties of the lens. Let's get all that together and let's make a prediction based on those things and how much curve you should see. You didn't do any of that. But that's what you should do if you cared to seek truth instead of to deceive people.
I don't deceive people. I'm not sure what you're getting at with that.
Well, seek truth instead then, okay? Do the actual footwork to do the experiments correctly. Right?
Okay. Well, all of the laser tests and the camera tests I've done, you know what, and all the videos and everything I've seen, curve can be proven. In fact, I've got a video, if you want me to share it, of a NASA rocket shooting up into 160,000 feet elevation, and it catches the sun right there, local sun. So you know what? I mean, I don't know how far you want to go with this game, but
I mean, you've so far shown that you don't care to do actual investigation or do your own research into stuff. I mean, you were not happy with the flat earthers that were on my show. It was on Saturday night, right? You weren't happy with them because they were kind of disgusting people and they did a bad job. But here's the thing. You're a nice guy. I like that. I appreciate that. You're not insulting me. But you didn't do any actual like controlling of conflating variables, and that's probably a phrase you're not even familiar with. But that's something you need to do when you're doing science.
Sure. Well, I guess I didn't go that far, but 2 years being a mod in the official Flat Earth group under Nathan Thompson, I think that was
that's completely useless. Yes, I agree.
I walked away from that.
Absolutely, a joke of a person, an absolute miserable, horrible, vile creature, Nathan Thompson. He is disgusting, and anybody that would think that he's worth anything other than just a pile of garbage is wrong.
Yeah, I can't disagree with you on that. I'm just saying I did my time. Now, you know what? I'm sick of the ballers that think that they want to be keyboard warriors and tell flat earthers how stupid they are and insult, and that's all they got in their table, and they've never even used a goddamn camera, to go test anything or prove anything. Y-axis curve has never been proven.
I've already shown it to you. Stop lying. Why do you gotta lie? I've documented it, and all you had is some lame excuse.
Go to Dwayne's video where he uses the infrared camera, and you will clearly see there is no curve using an infrared
unaware
camera.
of Dwayne having an infrared camera.
It's I think it's his last video that he did. He uses an infrared camera, which takes away the light distortion.
No, it doesn't.
From a regular camera. Yeah, it does. Yeah, it does.
All right, so he has high altitude balloon 25, which appears to be a lot of distortion. And that's it. He doesn't have any that I see of infrared. So I showed you number 24.
Yeah, give me a sec. I've got it in here
18
somewhere.
shows a curve, by the way.
It's 15.
15 is not infrared, and it shows a curve. Oh, it is infrared. Hold on. Let's see here.
Mm-hmm.
There you go. I'll share it. People can see it. Is this the same lens? Let's see here. It's a GoPro. You want to go with a GoPro? You want a GoPro lens? Let's back up a second.
Sure.
I want to make sure. Do you want to go with the GoPro? You complained about the GoPro on top of Mount Everest. Do you want a GoPro as part of your citation?
The point with the GoPro, if it's below the horizon, then the Earth goes this way. If it's above the horizon, the Earth goes this way.
Okay. So when is the GoPro acceptable?
When it's level with the horizon, you're not going to see a bend.
Okay. And I already showed you the little piggy camera.
Mm-hmm.
You didn't like it because it showed the curve of the horizon, and it was a GoPro.
I've seen that little piggy camera video hundreds of times, and I've never seen it do the curve thing. So
you didn't do your own research then.
That's new to me, and sorry, back in the day, I was balls deep in this game. So,
all right, now the problem is you're not gonna like it. You're just gonna hand wave it away.
Yeah.
All right, I'll share this to you, Tyler. You shouldn't have brought this up. Just warning you. But all right, here you go. Here's Dwayne's infrared. Now the infrared's in the bottom center. I don't know what the bottom right is. There it is, infrared. What do you see?
Yeah.
What do you see? Now this is 54,000 feet only. Let's see if we can find a spot that's higher. 27,000 there. 112,000. What do you see? What do you see in the bottom center there? Your evidence, Tyler.
Mm-hmm.
What do you see in the bottom center?
Well, there should be more curve than that.
How did you calculate that? Show me your calculations.
That's not my balloon, so I don't know.
Okay, so don't tell me there should be more curve than that if you didn't do the calculations to know how much curve should be visible with that camera at that elevation. So this was your citation. You wanted Dwayne Kellum with the infrared camera, center frame.
Yep.
There it is, curved.
Yeah. Well, you watch the whole thing, and the balloon, when the balloon moves, it bends the Earth both ways. When you catch it.
I got it. Now you don't want the GoPro anymore. I didn't.
Not saying
that. That's why I asked.
The balloon, the camera goes up, the Earth bends this way. When the camera goes down, the Earth bends this way. So now we're living in a bowl. Okay. You can go argue it both ways, bro.
But why would you bring this up? I asked you specifically, very specifically, do you want the GoPro? You said that's fine. If it's center frame, it's accurate. This is center frame.
Fully aware. It's the same thing as the Everest video. He used the climber was using the GoPro.
This is your evidence of flatness. You wanted this one to be shown. I'm showing this at your request. This is the one that you...
No, I didn't claim this as my evidence.
You absolutely did. You said, get the infrared one. And I asked you before I showed it. I specifically asked you before I showed it, if you wanted the GoPro, you said, if it's center frame, it's fine. Here it is, center frame. You are deceiving people again.
Michael, when you watch a balloon that's got a camera attached to it, the balloon wavers. Okay, you can catch it in both ways, this way, and when it stabilizes, it's flat. That's a basic, dude. You don't need no measurements for that. I can't believe I don't even know what you're doing.
Horizon's curved.
Well, then what happens when you're looking at a GoPro and the horizon's like this, and Earth looks like this? Come on.
You wanted center frame GoPro. That's center frame GoPro right there.
Nah, you keep going. There's no curve. Once it stabilizes, there's no curve.
You asked for this. I told you wouldn't want it. And I was right. It's like I'm a prophet, like Eddie Reese.
Okay.
Eddie Reese is a prophet and I'm a prophet.
Hey, cheers, man.
Yep. What do you got? I got Toonshine.
Toonshine?
Yeah.
This was a little bit of water, and this one is an Arnold Palmer.
Okay.
So we can just have fun with this, man. Like, I'm not one to take other people's work and to do math and try to figure out what this and that. I mean, come on. I don't got time for that.
All right. So all right. You mind if we get a couple questions from the audience then?
Let's do it.
All right. Chronic Avenger says, if you have a 10-foot 2x4 with a slight curve of 1 degree, would you notice it looking at the plank perpendicular or along its length?
1 degree?
Yeah, just 1 degree of curve. A 10-foot long 2x4.
Well, if there's a curve, there's a curve. If there's not, then it's a flat 2x4.
But would you see it from the side?
Well, a 10-foot 2x4 compared to 250 miles of ocean? Huh.
It's actually about degrees. Because 250, sure. if you're seeing 250 miles left to right, which you probably aren't, then we know how many degrees of curve there should be. Right? For example, if the camera is showing 70 miles, there should be about 1 degree left to right curve. Difficult for the human eye to see a 1 degree left to right curve. That's why when you buy wood at the lumber yard, or at the yumberlard, as my dad used to say.
Sure.
Anybody's dad say yumberlard? Tell me in the chat if yumberlard, if that's what your dad said. He thought it was funny every single time. I'm looking for my, where did my thing go? Anyway, so you look down the end of it, right? You don't hold it sideways.
Yeah.
I'm looking for a window. I have so many tabs open. Just so many tabs.
Yeah, me too. That's fun.
Oh, I think I know. I closed it. I closed that window. So, all right, I'll open it. I gotta do it again. All right.
So this was you wanted avatar stuff. Do you want to? I'm not gonna debate on the measurement stuff because a lot of that stuff I was not involved in, so I don't know distances. I don't know height or whatever.
Well, let me tell you this. If you actually do the math instead of being sloppy about it, you'll have a drastically different result.
Okay, well, what's your math? Where's your personal video or personal picture showing a curve on the y-axis based on your measurements?
It is the only way to do science. Is the only way to do science personal, because you've shown non-personal measurements. So, I mean, that's not your standard of evidence. So I won't be held to a different standard of evidence than you hold yourself to.
I'm just asking, do you have anything that you've done personally?
I certainly do. I measured the radius of the Earth 4 times myself.
Okay, well then the radius of the Earth goes back to the 8 inches per mile squared, which is the only way you can calculate 24,901 mile circumference.
Not at all the case.
The math adds up on that.
Oh my gosh, there's so many. Tyler, all right, in the United States, we got people in different countries, but in the United States, math is only required up to a certain grade level in school. Now, I took calculus in high school, and then I went on at university to take a lot more math. Did you take calculus in high school?
No.
Okay, did you take, typically your senior year, it's not required. Did you even take math your senior year?
Of course.
Of course. What math class was that?
I think I did. I think my end was trigonometry, but it was boring.
Can you solve a triangle?
Yeah. Yeah, I remember that.
So if you have a triangle, 90 degrees, 3,000, and 45 degrees, what are the other sides?
Dude, 3,045 on the one side.
90 degrees,
3,000
unit long side, and then a 45 degree angle. So you have angle, side, angle. So I've given you two angles. What's the third angle?
That would be 3,045.
No. The third angle is going to be 45. So it's all right. It's all right. But yeah, I'll show you one of my favorites that I did.
Okay.
I flew back from, I live in Minneapolis. I flew from Anchorage to Minneapolis. It was through middle of the night. We took off late, and at night landed early in the morning. And middle of the night, I used the Theodolite app on my phone, right? So you can install it on your phone. The day before, I calibrated it at the mouth of the Kenai River in Kenai, Alaska, near Anchorage. And this was the picture that I got. So the way that as I prepare the screenshot, the way that the Theodolite app works is it draws a horizontal line at eye level on the screen. So you can test whether the horizon rises to eye level, because that's a common claim. It's Eric Dubé's claim number 2. So here is the picture I took. You see that horizontal line there?
Mm-hmm.
There's actually, if you look really close, there's two of them. One is at eye level and the other is at 0.1 degree up from eye level. But
Okay.
they're essentially almost overlapping. And then that circle there, that's the moon.
Right.
So the entirety of the moon was below eye level. And then farther down from there is the horizon. So the horizon did not rise to eye level. The moon didn't even rise to eye level. So, and I'm at 35,000 feet there. You can see that on the top, 35,091 feet.
Cool.
So how is the moon not even rising to eye level, much less the horizon?
I'm not sure what you're actually asking here.
Well, it's
You.
a common claim of flat earthers that the horizon rises to eye level.
Uh-huh.
And it must if the earth is flat. Because of trigonometry, you can
Sure.
right? It has to because of just the geometric nature of it, right? The geometry of it. So in fact, because with refraction, it should be a little higher than eye level, but it never gets to eye level. Why?
Well, the moon's an interesting thing. Let's see.
But I'm asking you, why did the horizon not rise to eye level?
Well, based on how high you are.
Okay,
I'm not sure what you.
we can do the trigonometry. This was at 60 degrees north latitude.
Okay.
You see that? It's at the top of the screen there.
Okay.
Right. And I'll draw a little picture here. There's the flat plane. Right? So I'm testing the hypothesis of flat Earth, right? There's
Sure.
the flat plane. Here's the airplane I was in. Now, how far from 60 degrees north latitude to the edge of the Earth, the farthest away we could get where we know that there still is Earth? Well, I'm at 60 degrees north, so it's 60 degrees times 69 miles per degree just to get to the equator, and then another 90 degrees to get down to 90 degrees south latitude. And some people say the Earth continues. Some flat earthers say that's where the dome is. But certainly that's our minimum distance to go. So I'll do this. We got 60 degrees there. We've got 90 degrees there. Right? 60 and 90. So we can do a little bit of math, and we can find the absolute closest to the edge that I was at the time, right? Which is 150 degrees latitude. Multiply that by 69 miles. We get 10,350 miles.
Okay.
Okay. Now I'm at 35,000 feet. How many miles high is that?
35,000. That's about what, 6?
We got, I'll just convert feet to miles. We've got 6.62, 6.63 miles. Let's call it 7. Let's be generous.
Yeah, I'd say 7, somewhere around there. Yeah, 52.
All right. So we've got it now. What we've got here. And I'll switch so that people can see.
33.
We've got this. We've got this triangle here. Right, you looking? We've got on this side here, we've got 7 miles. And all the way across here, we have 10,350 miles. So we can solve that triangle.
Okay.
So how do you solve that triangle?
Solve a triangle.
Yeah.
I'm not sure what you're getting at, bro.
So we homeschool our kids. That makes me, I'm the math and science teacher. Math is
Okay.
we teach solving a triangle around 8th grade. So that's all right. I cheat anyway. I put it into a triangle calculator myself.
Yeah.
So
That's cool, yeah.
we've got side angle side, which is a solvable triangle.
Okay, but the triangle, the trigonometry stuff, like, come on, man. Like, observable, optical.
Hold on. I know you're trying to squirm out of it because before we get to it, because you know it's coming. That's okay. That's okay. So we've got right here. If we do, we've got there. That's why I need to take that. The angle there. So now to be pure, it's never, even on flat Earth, actually truly at eye level. It's always a slight dip. But the dip is extremely small. So here we got with a side of 10,350, a side of 7. The angle of the dip of the horizon there is off of 90. We got to subtract from 90 there. But it's going to be 89.961. Right there at the top. That's our angle of that triangle. So I'll draw the triangle. It's going to be dramatically
Okay.
out of scale. But that's why this right here. That's why Eric Dubay, in his 200 proofs that aren't proof, says that the horizon rises to eye level, because if the Earth is flat, it must, because from 60 degrees north latitude, it should be less than 0.1 degree of dip.
Sure.
Less than 0.1, but in reality, at that height, we measure about 3.5 degrees of dip. So that's why the horizon rises to eye level claim is always claimed by Eric Dubay, but nobody ever measures it. They always do this sloppy garbage with no measurements, no math, no calculations, none of that. So
Michael,
I
can agree with you right there, because I have never been a fan of Eric Dubay's work. So
he's not the only one.
Oh no,
that says he's not the only one that says the horizon rises to eye level, and it is a necessity. Though it doesn't matter who says it, it must, because we can just calculate the consequences of a flat Earth and know how far you are from the closest edge of the Earth.
Yeah.
And the horizon must dip less than 0.1 degree.
At what distance?
10,360 miles, 350 miles.
That's not a globe then. There's no way.
I'm testing flat Earth. I hypothesized a flat Earth. See, this is how you actually do science. You make a hypothesis. I'm hypothesizing that the Earth is flat. I'm doing an observation. The observation's from an airplane 7 miles high, and it is 10,350 miles from the airplane to 90 degrees south latitude, which is where people say the ice wall is, or the dome, or the edge of the circle before you get to the lands beyond, or something like that. It's different. Different people have different claims. Doesn't matter. What I did is I took the absolute closest of all of those claims. So unless you have a different one that's somewhere, you could tell me, but right. And I calculated the consequences of that hypothesis. That at 7 miles elevation, the angle should be less than 0.1 degree of dip. But there's a 3.2 to 3.3 degrees of dip when you actually measure it. So how do you rectify that? It doesn't match with flat Earth. So I look at that doing science. I say it doesn't match. That does not support the hypothesis.
Right, right. Like I said, I already told you in the beginning, I'm not hands down a solid flat earther, but the spinning water ball thing is just beyond hilarious because y-axis curve has never been proven.
You keep
And
saying
if
that
you wanna-
mantra, but I've shown it to you.
If you want to use
Three
the sun,
different videos I showed to you, including one that you wanted to show.
okay, let me pull one up right here. This is a short one.
Is it a high altitude balloon?
It's NASA's rocket.
Is this your audio?
Yeah.
Okay.
And it shows a local sun. So if you want to get into the sun and the moon anomalies, you know what? I don't think they really are concrete evidence to prove either one, but this one right here.
Yeah.
There's the table again. And the sun's right there.
Why did you play that? There's a curve in that. Can you send me that video? I want to use it. I want to add it to my list. There's curve in the
Sure.
horizon.
That's expected.
That's the fourth time that two of them from me, two of them from you of the curved horizon. Tyler,
I
what are you
know.
doing?
Because this is the fun part.
You're
'cause
shooting
when you-
yourself in the foot.
Yeah, are you expecting
Again.
to see a straight line?
Again. Yeah, you are.
That's the funny part. You guys think that we're supposed to prove that it's like absolutely
You
straight.
just showed the curve of the horizon again, Tyler. So you keep saying the curve of the horizon's never, the left or the y-axis never been documented using the definition that we agreed on, and 4 times it's been documented in this stream, twice from your choice.
Well, cheers, you win.
Welcome back, Tyler. So I don't know why you would think this is anything that you'd want to show. This is yet another.
This
Gosh,
video right here.
doesn't your foot hurt from getting shot so much?
No, the funny part about this video is that that's why I said in the beginning of it, you're going to see curve. Don't get too excited. But the point is that the rocket is showing a local sun. So I'm sorry if
How is that a local sun?
you can't prove the sun is 93 million miles away.
How is that a local sun?
You ballers have a problem.
How is that a local sun?
It's right there.
How? How is that a local sun? You're showing the glare of the sun. How is that a local sun? It's just glare. Put a solar filter on it.
That's not my camera again.
Okay. Well, then you have a camera with glare on it. Whoop-de-doo. Oh
That
my
was
gosh.
NASA's own camera.
Yeah, they didn't put a solar filter on it because they don't want a solar filter on it because they're not getting video of the sun. Oh dear.
Yeah,
Tyler,
they
this is
didn't.
awesome. I love this. Thank you so much for. So don't again say anything about the left to right curve of the horizon. We've looked at it 4
Hey.
times today. All right, I'm going to ask some more questions here though, because Rob J says show him the missing square problem. C curve. What?
Missing.
The missing square. Rob J, I don't know what you're talking about. This is not familiar to me. Well, there you go. That was from Rob J. I don't know what. Dave Rogers says none are so blind as those who refuse to see. Sage words. Sage words. All right. We got Mr. Shigura says he's a Poe. Worse, he's a boring Poe. Are you a Poe?
Me?
Tyler, yeah. Are you a Poe?
No, but I am a songwriter.
Okay. Do you know what a Poe is? I don't know if you.
Poe?
Yeah, a Poe.
Oh, I thought you said poet.
No, Poe. P-O-E. Do you know what that is?
No, what's a Poe?
A Poe. So a Poe is typically that means they're accusing you of being a fake flat earther. So Poe comes from the phrase Poe's Law, who was a guy that debated people that sometimes people try to go in and pretend to be somebody so ridiculous and make ridiculous claims that you can't actually tell between somebody trying to be ridiculous and somebody who's actually holding that position. That's the point.
See, let me go ahead and explain to your audience how this because at one point I was a devoted flat earther, like hands down, and being a mod in Nathan's group, 125,000 people in there. Okay, saw all the arguments, I saw all the evidence, I saw all this and whatever, and then it was right before I got invited to go to the Denver conference, the Flat Earth conference, that I started figuring some things out. Mainly Bob Nodell, okay, Jaron, D Marble, Mike, Mad Mike, whatever, with his silly rocket thing and whatever. And I got some inside info, and they were all pretty much, they signed a contract in the beginning to go along with the flat earth narrative. And then right towards the end there, after they released the Beyond the Curve movie that came out where Bob did the laser gyroscope thing, that's when all their contracts ended. And they all got paid some pretty damn good money. And I saw this whole thing happen. And so that's when I threw my hands up and walked away, because it was just another deception. But it was true that with all my research personally, I mean, you're probably better than math than I am, but I'm probably better at numerology than you are.
Numerology is a joke, so I don't care. I despise numerology.
Okay, well, take it with a grain of salt, but there's a lot of truth in numerology. But
never.
Anyway, so that's when I kind of just says, holy shit, have I wasted like really the last 2 years of my life like looking into this? Because it's the whole movement, even with David Weiss and his flat earth application watch thing. But
yeah, the scammer.
Everywhere I've ever gone with all my camera equipment, I've never been able to prove what they say proves a ball.
Yeah, but you never did the math to actually test it. So if you want, I'll help you do the math. I get it. It's not your thing, but I'm glad to show you how to actually apply the math so you can have a proper hypothesis.
Well, sure. I guess that could be in another conversation, but everything was based on 8 inches per mile squared. And even the infrared photo from Oahu to Big Island, during the volcano in 2017, you should not have been able to see the volcano because there should have been 16,500 feet of curve
Using the wrong math.
covering Big Island.
Yeah, using the wrong math.
Well, then what would the math be? 550 observer height.
Well,
Maybe
we can
do-
plug that in right now. So hold on. You know the distance between the two, and you know the height.
Yeah, 550 feet observer height.
All right, I'll share this to you, and we'll plug it in right now.
And the distance, you can just sum it up, 200 miles. In fact,
How accurate is that?
let me pull up. Hold on. I'll get it up here.
All right, the height is 500 feet. You said
550,
okay, and the distance is how far?
200 miles.
We can pull up a map and we can look.
Okay.
And what's the other target? What's the mountain that we're looking at?
It's Mauna Loa, which has a height of 13,600 feet.
Well, you should see it.
You should see it.
You should see it.
That's what it's saying.
Yes.
Drop it. Well, where is this cat?
Walter
So how
Bislin Advanced Curve Calculator.
How much curve are you supposed to see in 200 miles?
How much obstruction? There should be 8,400 feet hidden. Now this is 0.5, a coefficient of refraction of 0.5. Don't know. I'm going to guess maybe that's a little high. I'll put in 0.33, which is what the American Meteorological Society uses. Still should see it. And that says 12,000 should be hidden.
And the island is 13,600, and you can see the entire island. So
I'd like to see the photograph of the entire island.
let me do screen share, and I've got it right here.
I'll stop mine and you can switch.
Let's see. Right there.
All right. And how did you determine that's the entire island?
Because of the dark lights.
That's all the lights on the entire island?
For Big Island, yeah.
There's like no lights along the shore?
They're right there. The bottom one shows
I see just like one light on the left and two lights on the right. Is that correct?
yep, those are the two main docks right there on Big Island.
And there's no other lights on the Big Island. So all right, so this is from which island?
From Oahu.
Which one's Oahu? I don't know Hawaii that well. Oh, there's
Just
Maui. There's that. The Big Island is Honolulu's on Oahu.
Mm-hmm.
All right. Yeah, all right. We got 200 miles. And you see, and where's the other islands? Are they in this picture?
Not in this one. But this is the best one I could.
How do you not see the other islands? They're when I look at the map, they're right in line.
Because they're in between
They're
From
like,
Oahu to Big Island.
yeah, they're like right to the side of it.
Mm-hmm.
Okay.
I've got a few more I can show,
So,
but
I'm confused how that entire island can have a road going around it. The entire perimeter of that island facing Oahu has a road going around it, yet there's no lights on that road. How did that happen?
It was during the volcano, and they were in evacuation mode.
So they turned off the street lights?
I'm not sure about
Hmm.
that, but you're not gonna, even if there was a car with headlights right there, 200 miles away, you're not gonna pick that up.
Yeah.
That's why if you Google search Oahu to Big Island to try to find a photograph, you're not gonna find one. This only was possible because using an infrared lens while the volcano was going off is this is one of the only photos that you can even find that shows the Big Island from Oahu. So 200 miles and you're telling me 12,000 feet of curve should be there, but the entire island's right there.
The problem is now I'm looking at the map of it. It's all there's stuff all along the shore. Why is that not putting light out?
Is what?
You got a 15-minute warning from your wife.
Oh.
That's all you get. Wrap it up, guys.
All right.
Thank you.
Oh gosh.
This has been fun.
All right, let me see if there's any. We'll get to see if there's any questions. You got to respect that.
Sure.
All right, if you stop your share, I'll get you on and we'll go through these. If you don't mind, I have a bunch. Let's see. All right, this is a long one, and it probably isn't something to answer because I think it's a little tongue in cheek because it's a lot of math. Steve 6464 says Tyler, the Earth is 5,000 million billion trillion 5 quadrillion square feet. You take up 2 square feet. You are 0.00, lots of zeros, and then 3, 4. He has way too many significant figures in this. Of the Earth, at that small percent, how much curve do you think you should see? He went crazy on the numbers there. Not a whole lot, is there? All right, Eddie Reese. Okay. Eddie Reese is holding your feet to the fire. He says, Tyler, do your own research. Also, Tyler, well, I didn't measure it. How can you not see the hypocrisy there? Tyler, I'm happy to show you the math anytime. Right? 8 inches per mile squared is not it. Let's see. Oh, that's a good idea. We've got Lael for $5 says if that guy is on top of Mount Everest and the sun is at minimum 3,000 miles high above the peak, how can the sun rise from under the clouds?
Anomalies. Sorry, it's not 93 million miles away, but it's definitely its own thing.
It's been measured, and you don't have measurements. So when it comes down to it, I'm going with measurements.
I just pulled up.
So
this right here. I mean, go ahead, explain this if you want.
I'm trying to honor your wife, dude. We're moving. We got to move. We got Andrew Rouse says, hey, don't make fun of me, Tyler. I'm a bowl earther.
See, so there's the sun. How do you explain the sun being in the clouds right there?
Put a solar filter on. The sun isn't actually just the height of the clouds. That would be absolutely mind-blowingly ridiculous to think that the sun was just like 4 or 5 miles high and you could see it over half of the Earth at the same time. It is beyond ridiculous, but you go with that. Beyond ridiculous is all right. Let's see. For Melissa says the infrared curve goes against the distortion. So in other words, there is more curve than the camera shows. Flatties debunk flat Earth. I think that was about the Dwayne Kellum infrared. I'm doing these out of order, people. I'll come back to them.
Fair enough.
It's a good one. All right. From Almarju. What if the camera is a little zoomed compared to the other camera? You won't see much of the curve because it's limited to zoom in the screen from side to side.
Not with the wide angle lens.
Yeah. And the challenge with wide angle lenses is they're easier to make if they have more distortion. So you pay more money to get a wide angle that doesn't have as much distortion. It's a challenge. Oh,
well,
this.
Like I showed the one photo with over the ocean with the all the military ships. That was from a military helicopter with a wide angle lens.
Yeah.
And I'm sorry, but yeah,
But you didn't know the elevation, so it's not useful.
Yeah, I wasn't there.
So all right, well, you don't have to be there if they document the things. If they were to tell you how high the camera was at or the details of the lens. Now Grithog is saying that you are giving Bob and Jaron a run for their money. Maybe you will like that because you don't like Bob and Jaron. Did you wind up going to the convention in Dallas?
Denver?
Denver, yes.
No, I didn't. When I saw the game kind of started unfolding, and then at the end there, after I watched the movie Beyond the Curve with Bob and had Nathan in there and Jaron, and I was just like, I got sick to my stomach watching that damn movie. And
all right, let's keep moving. Your wife says move on. Question from Lord Illuminous Pooh. How many sides on a triangle of 1, 1, and 1?
Would be 3.
It's a trick question. You're right. You got it.
Okay.
Stringer News 1 says, Tyler, I got your nose. I got your nose. Oh, wait, that's just my thumb, but I bet you were real scared for a minute there.
Okay.
Nice one. Stringer News 1.
No, it's still right here.
I love doing that to little kids. All right. Luke Filewalker says, Flat Earther, there's a hot spot there for a local sun. Also Flat Earther, let's ignore the curve and the rocket not hitting any sort of dome. There's that little bit of a problem there. And tell you what, in that video of the space shuttle going up, the supposed local sun was not in the clouds. It was way higher than the clouds. That didn't quite fit, did it?
Like I said, anomalies, they don't fit. Pilots can film the sun in the clouds. I've got hundreds of videos of that. And we can film the sun in the clouds. But then other times the sun it looks like it's far away, but there's never been any proof that it's 93 in numerology, 93, they flip it around, there's 666. Like, it's all pretty simple.
Yeah, 90. It's just been measured, though. It was measured to be that far many times in many different ways.
Yeah,
all right, let me do this, though, because your wife is in the chat here with your account hounding me.
She is?
She's like, you got 9 minutes.
Yeah. Chill.
All right.
No, just kidding.
How about this, Tyler? I'll let you say just do your closing stuff, and I'll let you go, and then I'll get back to talking with the audience a little more. How about that? I don't want to get you in trouble.
Oh, you're fine. No, she's fine. No, I appreciate this.
I didn't say it.
Yeah, I didn't come in here as looking for a debate or I know I'm not going to convince you otherwise, and I appreciate you bringing up the mathematics stuff because I've just been more of an observational person. Believe what the camera shows. because I haven't, everywhere I've been on tons of road trips, and on everything I've done with my infrared P900, P1000. From everything that they've said as far as curve goes, I've always been looking like, just show me that I'm doing something wrong or whatever. But the spinning water ball thing is way out of the ballpark. I mean, even NASA should be like your worst enemy with all this, like, because they screwed so much stuff up. Their ISS, their water pool, spacewalks, and all that garbage.
Yeah, Jaren's gonna love you for that.
Jaren's a traitor.
No, but I mean you just basically quoted Jaren right there.
Yeah, well, Jaren, he did the cartoon thing in Beyond the Curve, and you know, he played along as a flat earth the whole time. Well, then what happened as soon as all their contracts ended, acting like true flat earthers, they all went, Daryl Marble got a new RV, Bob Nodell bought himself a new house, Jaren, I don't know, whatever he did, whatever, but then that's when they all disappeared. It's like, and then Patricia Steer, Mark Sargent, he's a cockroach. Yeah, I don't care. Share this with them, because that's the truth.
I don't care. I think the Fleur fin fighting is fun. It's good comedy. But okay. Thank you to Mrs. Tyler for keeping him on schedule and lending him out for 2 hours. Tyler, thanks for coming. It was entertaining at the least. And seriously, if you see something and you're like, what does the globe predict? I'll tell you. Just ask me. All right.
Yeah, we can do this again if you want. But yeah, great. Appreciate all your work, and to the audience, I hope you enjoyed.
All right. I'll let you end your session on your own there. But and then I'm sticking around. I got a little more to talk to with the audience here, so
Okay.
whenever you want there. So all right.
So what I do, just put
Bottom, yeah, bottom right, there's a exit or
Oh,
end. It should be red, and yeah.
there we go.
Thank you. See you later.
All right, Michael. Take care.
Okay, people. There it is. I'll end it. There it is. It's all done. All right. Well, that was entertaining. I've got a few more super chats to go through here. I'll read them quick. I'll go back up to the top and read them in order. Yeah, that was some hand waving. Definitely some denial. Some goalpost moving. Well, I mean, we're all used to it. He's a nice guy, though. Luke Filewalker for €5 says, and that moment when nope is your best argument. Yes. He actually said that. I mean, it's like he's got his pre-selected conclusion. So, Eddie Reese for $2 is not hard to see why Nathan Thompson made him a mod. You know, Nathan's super rude and disgusting, and Tyler was not. So there you go. At least that didn't rub off on Tyler, because some of Nathan's friends are very uncool. Most of them already got rid of them. So Alyssa for $5 says, let's see. Oh yeah. Tyler, why do I have to count for Earth's curvature whenever I want to calculate my flight distance? Tyler, if you're still watching, he's a pilot. They have to account for Earth's curvature when they do their distance calculations. Connell Silver for $5 says, are we really surprised when the flat earthers have no evidence? Are we surprised when they duck, dodge, deceive? No, not really. Flat Earth is dead. Duck, dodge, deceive, dead. Leia, we got that one already. Brimstone for $5 says, that hula hoop analogy was perfect, and it fits into the whole direct observation thing I keep hearing about from flat earthers. Will it work? No. They how come I don't see curve? How much curve should you see? I don't know. Done. Then you have nothing. Do the work to see how much curve you should see. Or use one of the couple online things to do it for you. You could put in, I think Walter Bislin has one, where you can put in the details of the camera, the elevation, and it'll show you what you should see. So, Connell Silverfirst says for $5, when flat earthers deny what is right in front of their eyes, when they refuse to research or even click links, they show their ignorance is a choice. That was funny. 4 times, left to right curve. 2 from him. 2 from him. And he still went back to the mantra, claiming that there wasn't any. I see T Brown in the chat. I got a couple minutes if you want to come in, T. Send me an email. But I'll get to you, T Brown. I'll get to you in a minute here. Kango44. Is that different? Your name's different. For 5 New Zealand dollars, says just walk from one place to another. You can measure the curve. The flat earth is just so dishonest. I don't know how walking. How do you measure the curve from walking? Unless you walk really far, get a distance. That'd work. Be a long far. All right. Andreas Eld for 26 says, my dad says Red Gorin because he's Swedish. So I think this was dad joke time when my dad would always say going to the Yumberlard. Oh, that must be lumberyard in Swedish. Because then, yeah, because Andreas came back again with 26 again and says, gave me the pronunciation. Red Gorin. Red Gorin. The D is soft or hardly pronounced, maybe? I don't know. Green Bull for 5 Canadians says, Tyler has the best globe evidence. You should bring him on to debate a flat earther. Exactly. Like, oh, never mind the curve. It's not a fisheye lens. Never mind the curve. But the sun's local because there's a glare. Awesome. Mr. Shigura for 199 says 2 years as a flirt mod and hasn't heard the Poe. Hadn't heard Poe. It's an echo chamber. They don't accuse each other of being Poes. They can't see. They don't see how ridiculous they are. So Mr. QTube first name Fa says by on schedule, do you mean kitty whipped? Ooh. I like Luke Filewalker says, I got a picture of clouds which are lit up from below, which would suggest the sun is below 1,000 feet on flat Earth, debunking the local sun claim. Yeah, I mean, they'd have to burn the local sun in the clouds. Seriously, from the Midwest, where we are many, many miles north of the Tropic of Cancer, if the sun is in the clouds, it's in the Midwest. It's can't even be south of the Tropic of Capricorn or Cancer. How is that the case? How is it able to light up half the Earth if it's right here close to me, right in the clouds next to me? It makes no sense. That's why it's such a ridiculous claim. If they thought, that's the problem. If they thought, they wouldn't say that. All right. Mr. QTube about being kitty whipped. I hope she's not watching. Stuart Christmas, Lloyd's brother, says for 29 Singaporean dollars, says my PhD is in optoelectronics. So strange. I never learned shining light on straight lines makes them appear curved. You learn something new every day. My old professor will love to hear this discovery. There you go. All right. Let me make sure I didn't miss any. Let's see, I got that. I got checking them all. Looking good, looking good. All right. So T Brown is in the chat. He's complaining My $10,000 sextant challenge prohibits you from using the globe in the calculations, which of course any flat earther would completely agree with, because why would you want to use the globe if you think the earth is flat? So for example, the Nautical Almanac has all of the sphere, the stars plotted in a sphere, which is concentric to the globe. Well, unless you think the earth is a sphere, T. Brown, why would you want to use spherical star charts? That doesn't make sense. Maybe you want to project them onto a disk, you know, basically the AE projection. Well, the stars are directly above points on the earth. So you've just then used you just made the AE map too. Is the AE map the map that you want to use? Because we can test to see if the AE map is correct. It's not. So T. Brown, you have a little problem there with number one. Number two, the site reduction tables, which are used in the Nautical Almanac. Here's a little, you're going to love this. It's modeled, geometrically modeled using trigonometry from a sphere with a specific radius. T. Brown, you're going to need R for that. Ouch, T. Brown. So, T. Brown, assuming a hemisphere without proving the Earth is a sphere is a begging the question, has nothing to do with celestial navigation here. We're not talking about how to do it on a globe. We're talking about how to do it on flat Earth. You don't get to use a sphere if you think the Earth is not a sphere. That's the begging the question fallacy that you want to use. The site reduction tables are based on a sphere with a specific radius. Now, if you wanted to calculate the distance between 2 points on the surface of the Earth, to do the celestial navigation, you would need to use a formula that doesn't rely on the Earth being a sphere with a certain radius, like the Haversine formula. Because in order to use the Haversine formula, you're going to need R for that. T. Brown. Not very good for you. So he says, I love this, latitude lines on maps are elevation angles of Polaris on a flat Earth. In fact, they're not. Draw that out, T. Brown. It won't work. I've seen it. It totally fails. So, yeah, T. Brown, show the math. Send it to me. I'll put it up. I'll feature you. I don't know why you're scared to come on here, T. Brown. You just come on right now. We'll go through the math together. Don't worry. I can handle the math. Okay? Whatever math you bring up, I can handle it. Seriously. So anyway, send me an email, mctune@mctune.net. You can come on right now, T. Brown, and air your grievances. But no, nothing at all. So peace and long life, MC Tune says. Big thing, Bruce Wayne. Bruce Wayne? Like Bruce Wayne. So anyway, Tune can handle it, T. Brown. Can't. Anyway, well, T. Brown, I got nothing from you. No email yet, so what's up with that? You're just gonna sit there and keyboard warrior? You got like your shield. Is your shield like, is this your shield? Is this what it looks like? Is that what your shield looks like to defend you from me? You just stand right here like, oh, I don't want to talk to MC Tune. Is that you, T. Brown? I think so. All right. Hey, let's not come in for a debate, T. Brown. We can do that at a different time. You can just come in and tell us all the reasons why you think that you should use the spherical trigonometry from the Nautical Almanac to take the challenge. It actually has, there's no fallacies involved because it's not about using the globe to get the position. It's about using flat Earth geometry. Who said that? Who said that flat Earth geometry, or the geometry of the flat plane? Who was it? Was it, oh yes, it's Nathan that said that. Here's what he said.
Now, when you navigate around the flat plane, utilizing the geometry of the flat plane, then you get around without any issue.
So, T Brown, if you agree with Nathan Oakley, you should be able to get around using the geometry of the flat plane, not the geometry of the sphere. That's why you shouldn't be using the sphere stuff in there. So, got a problem? Yeah, it has nothing to do with globe celestial navigation. So you're deflecting to talking about how we do celestial navigation on a globe. It's not about that, T Brown. So set that aside and then take up your geometry of the flat plane and use that.
The sextant only works on a flat plane.
Flat plane. So use the flat plane geometry, as Oakley said.
Well, the proof of the flat plane would be that you arrive at your destination, right?
Yeah. The fact that
the
it
proof
works
part.
when it's utilizing a flat surface.
There you go.
You use it, you get where you're going.
When it's utilizing the geometry of the flat plane. So, how does celestial navigation use the geometry of the flat plane? It can't just use it in one spot. It's all gotta be it. So, T Brown, definitely if T Brown made a brown in his pants. All right, still nothing. No email from you. Well, anyway, T Brown, if you'd like, you could send me your detailed complaints about it. You could email that to me. I'll read them out if you don't have the guts to come on. I understand why you'd be scared, because I'm going to talk geometry and you can't do geometry. Is that it? I could understand that, right? Can you solve a triangle like that? Probably not. So anyway, that's what I have, T Brown. If you don't have any actual stuff, suck it up. You know, what do we say? We say sack up or shut up. So anyway, thank you everybody. I have a debate in 45 minutes with DMOC on the asylum. So he challenged me to a debate, and I said, well, what time? And he said he works until 11 tonight. So until 11. And during this last debate, I got a message from somebody on their server that was waiting at 9:30. Like, well, you're a little wrong on the timing there, but that's fine. So let's see, top of the fist. All right, so I'll read that later, but that's what I got. I'm going to wrap it up. We've got Stringer News 1 that says for $5, how did you arrive at your destination? He used GPS, global positioning satellite. So anyway, moderating the debate. They have two moderators. They have a globe moderator and a flat earth moderator. The globe moderator is none other than Mr. Dr. Bob the Science Guy. So that should be good. Definitely looking forward to that. So you should be there too. So all right, let me cue up the outro. So there it is. All right, everybody, thank you very much for coming. Thank you for the fun, Tyler. Thank you to Super Chatters, members, and patrons. It makes what I do spend more time doing it, really is what happens. So we'll see y'all later. Oh, hold on. Oh no! Oh my goodness. Okay, I got one thing. We got what? Why is this? Oh, this is the blanket. Okay, we've got. This is my puppy right here. This is poor dog. She is not doing well. This is Diamond. Her best friend Shadow died a couple weeks ago, and she is not doing well. She kind of stopped eating, so she's super weak. She's also blind and deaf. You can look, let's see if we can get her. You can see her eyes they're all covered. She can't really see. We've been getting her to eat a little bit, but it's a rat terrier. She's a rat terrier. This is Diamond. She's the sweetest dog. Super sweet. So, okay, here you go. Here you go. Like a baby. Thank you. All right, there. Have I tried appetite stimulants? I have not. How do you send me a message, Connell Silverfur? A couple days ago we thought it was done, and she's actually eaten a little more now. So anyway, that's it. Yes, Barsby, I guess you're right on that one. What did the vet say? The vet said she's very old and near the end. So yeah. But yes, that might do it. So you need to invest in a more comfortable chair. What? This is from Famous Dave's. One of the leftover chairs when they were throwing out, upgrading their stuff. Anyway, I was about to say goodbye before a dog showed up. We'll see you all in about 45 minutes.